In-class activity 11E, errors in hypothesis testing. Drug abuse is a serious problem among adolescents in the United States. The National Institute on Drug Abuse, NIDA, part of the National Institute of Health, funds studies that investigate sources and changes in drug abuse among teens. A study conducted by the University of Michigan challenges the idea that reduced adolescent use of drugs can be achieved solely by limiting the supply of the drugs. The data for the University of Michigan study came from the annual monitoring the feature MTF survey of substance use behaviors and related attitudes among adolescents in the United States. The MTF survey is given to adolescents and it is completed and submitted anonymously. Why do you think this is important to administer the survey this way? Answers may vary, but this is a sample answer. It is important to get accurate and honest answers to assess real change. Doing it anonymously increases trust and accuracy. Objectives of the activity. You will understand the types of errors that can result in a hypothesis testing and the reasons that type 1 and type 2 errors arise. Statistically significant results are not necessarily practically significant. Let's say it again. Statistically significant results are not necessarily practically significant. You will be able to identify a type 1 error and what affects the probability of making a type 1 error. Identify a type 1 error and what affects the probability of making a type 2 error. This should be identify a type 2 error and what affects the probability of making a type 2 error. Determine whether results have statistically significance. Determine whether results have practical significance. So we determine results that have statistical significance. And this should be type 2 error. Determine whether results have statistical significance and determine whether results have practical significance. So, question number 2. The NIDA was interested in the effects of the 2020 pandemic on drug abuse in teens. In particular, they were interested in understanding the change between vaping usage pre-pandemic and vaping usage 3 months into the pandemic. Before the pandemic, 24% of 12th graders reported that they had vaped nicotine in the past 30 days. The study included 582 12th graders who anonymously completed the MTF survey. 3 months into the pandemic, 17% of 12th graders reported that they had vaped nicotine in the past 30 days. A, what is the null hypothesis for the study? Part A, what is the null hypothesis for the study? The null hypothesis is P equals 0.24, 24%. P equals 0.24%. And what is the alternative hypothesis? Is that P is different from 0.24. P is not equal to 0.24. Part C, assume all conditions for a one sample Z test for proportions are met. using the DCMP inference by population proportion tool at this website, dcmatpathways.shinyapps.io/inference-prop. Calculate the p-value for the test. So using technology, calculate the p-value for the test. And when we use technology, we see that the p-value is 0.001, almost zero. This is a sample output. It's tiny, but once you enter the data into this, you will see that the p-value written here is 0.001. Part D, at 5% significance level, do you reject the null hypothesis? At 5% significance level, do you reject the null hypothesis? Yes, because the p-value is smaller than the significance level, we reject the null hypothesis. All right. Now that we reject the null hypothesis, what is the conclusion? Our conclusion is there is sufficient evidence to conclude that the proportion of 12th graders who vaped within the last 30 days has changed from pre-pandemic level. F. Was your conclusion in part E statistically significant? Was it practically significant? So we have two questions here. One, was your conclusion in part E statistically significant? Was it practically significant? This is our answer. We say yes, our answer was statistically significant. And the sample answer for the second part is, I believe that the results are practically significant. It is a 7% decrease in the incidence of vaping. Okay. G, can you be absolutely certain in your conclusion? In other words, can you be absolutely 100% certain of your conclusion? Well, definitely not. Technically, no. There is a possibility, though small, that we rejected the null hypothesis. That was true. So we cannot be 100% certain. We may be highly 99% confident, but not 100% confident. Why? Well, let's talk more about that. As you have on the lesson note, I hope you have your lesson note in front of you. Errors sometimes arise in hypothesis testing. This is because we are reaching a conclusion about the entire population based on a sample. We cannot eliminate hypothesis testing errors entirely. Sometimes, due to chance, the result of the hypothesis test does not align with reality. If we reject a correct null hypothesis, we are committing a type 1 error. If we do not reject a null hypothesis that is actually incorrect, we are committing a type 2 error. Let's say it one more time. If we reject a correct null hypothesis, we are committing a type 1 error. If we do not reject a null hypothesis that is actually incorrect, we are committing a type 2 error. So a summary of what we have said in table form will be this. When the null hypothesis is correct and we reject the null hypothesis, that is type 1 error. When the null hypothesis is incorrect and we do not reject the null hypothesis, that is a type 2 error. In these other cases, of course, there is no error. Number 3, describe in the context of question 2 a type 1 error. What might happen if a type 1 error occurs? This is it. This is a sample answer. There is actually no change in the vaping rate, but we committed a type 1 error by rejecting the null hypothesis and erroneously concluding the alternative that the vaping rate did change. The article reports that the federal minimum age for tobacco product purchases, including vaping devices and liquid, rose from 18 to 21 years and went into effect in early 2020. News reports on vaping-induced lung injuries may have also had a chilling effect on usage. So, if we make an error, then we might support those programs that were erroneously believed to be associated with a change in the vaping rates. Similarly, describe in context of question 2 a type 2 error and what might happen if a type 2 error occurs. There is a change in the vaping rate, but we concluded erroneously that there was no sufficient evidence to conclude that there was a change. If we made this error, then we might not support those programs that were erroneously believed to not be associated with a change in the vaping rates. In general, how might a type 1 error arise? Let's explore the sampling distribution of sample proportions under the null hypothesis. And there's a graph. The figure illustrates our hypothesis test decision rule. If the actual sample proportion is greater than 0.275, this is 0.275, or less than 0.205, this is less than 0.205, this is greater than 0.275, then we will reject the null hypothesis and conclude that there was a change in vaping rates. So this point and this point, to the right of this greater than 2.75, to the left of this less than 0.205. So, but what if the vaping rates did not change and you happen to select a sample proportion in the test shaded light blue of the distribution? In other words, you selected a lucky input that was simply unusual, given that the null hypothesis of no change was true. P is indeed equals 0.24, which resulted in a small enough p-value to reject the null hypothesis. In this case, you would have committed a type 1 error. Type 1 error. If we decide we will reject the null hypothesis when the sample proportion is greater than 0.275 or less than 0.205, what proportion of the possible sample proportions under the new hypothesis, P0 equals 0.24, will result in a type 1 error? Well, that proportion It is 0.05. Approximately 5% of the samples will result in a type 1 error. And I brought the graph here again. So we see it. This is 95%. So the leftover is 5%. From this to that is 95%. What is left is 5%, 0.05. Similarly, suppose that you decide to reject the null hypothesis when the sample proportion is greater than 0.286 or less than 0.194. 286 around here, and then around here. What proportion of sample proportion under the null hypothesis, P0 equals 0.24, will result in a type 1 error? In this case, it is 0.01, that is 1%. Approximately 1% of the samples will result in a type 1 error. Approximately 1% of the samples will result in a type 1 error. Question 7. What are the significance levels in questions 5 and 6? Well, the significance levels are 5% and 1% respectively. Question 8. In which scenario, question 5 or question 6, is it harder to reject the null hypothesis? In which case, is it in question 5 or question 6? Is it more difficult to reject the null hypothesis? It is more difficult to reject the null hypothesis in question number 6 because we restricted the probability of committing a type 1 error to 1% versus 5%. That is all about type 1 error. How might type 2 error arise? How might a type 2 error arise? Imagine that there really is a change in vaping rate, but you erroneously failed to reject the null hypothesis and concluded that the sample did not provide enough evidence to suggest that the vaping rate changed. As a researcher, there are two main reasons that you are not able to come to the correct conclusion. One, it is too hard to gather enough evidence to reject the null hypothesis. This is typically caused by the sample size that is small. This is typically caused by a small sample size. Two, it could be the case that the researcher simply had an unlucky sample and resulted in a large p-value. Number 9, suppose instead of sampling 582 12th graders, a different study was only able to sample 100 students. Suppose that this sample similarly showed that 17% of 12th graders reported vaping within the last 30 days. The p-value for the test is 0.1012. Part A, at 5% significance level, what is the conclusion of this study? The conclusion is that there was not sufficient evidence that the vaping rate had changed. There was not sufficient evidence that the vaping rates had changed. B, if there really was a change in vaping rate, what type of error did you commit? It is a type 2 error. We mistakenly failed to reject the null hypothesis. So it is a type 2 error. Question number 10. Is a type 2 error more likely to arise with a sample that includes 582 students or a sample that has 100 students? And why? Is a type 2 error more likely to arise when the sample size is 582 or when the sample size is 100 students? We say that a type 2 error is more likely to arise with a smaller sample size. That is, if we only sample 100 students. Similar question. With a significance level of 0.01 or a significance level of 0.1, that is, in which case is a type 2 error more likely to arise? Is it with smaller significance level or higher significance level? And this is our answer. A type 2 error is more likely with a significance level of 0.01. It is harder to reject the null hypothesis with a smaller significance level. Therefore, a smaller significance level increases the risk of a type 2 error. If you want to reduce the probability of a type 1 error, what can you do? Sample answer. You can lower the significance level or increase the sample size. This will help reduce the probability of a type 1 error. You can lower the level of significance or increase the sample size. Question 12, the last question. If you want to reduce the probability of a type 2 error, what can you do? Think about it. If you want to reduce the probability of a type 2 error, what can you do? You can increase the sample size or increase the significance level. So, to reduce type 1 error, you lower the significance level or increase the sample size. To reduce type 2 error, you increase the sample size or increase the significance level. Thank you, and I see you at the next video.